Let's investigate circles. What vocabulary do you remember about circles? Do you remember some parts of a circle? Maybe some different words come to mind, like a radius, a diameter, a circumference. So let's take a look at some of these vocabulary words that you may or may not remember. The center of the circle, the diameter of the circle, a radius of the circle, a sector of the circle, and an arc, a chord, a segment, a tangent, and a circumference. Those are just a few words that hopefully refresh your memory for some circles. Well, when do we learn about some circles? In 7th grade, our standards are solve real-life and mathematical problems involving angle measure, area, surface area, and volume. So notice that the students need to know the formulas for area and circumference of a circle and to be able to use them to solve problems. They need to be able to give an informal derivation of the relationship between the circumference and the area of the circle. This is a great activity to try. So everyday circular objects. Find 3 to 5 circular objects around your house and record your notes here. So think about some objects that you could measure. Maybe you have a water bottle or a container of oats or Pringles that has a circle on it that you can measure. You could measure with string or a yarn or ruler or something else. Think about what units you're measuring in. Normally we measure in metric units. So trying to measure in metric units is a good idea. It's also a little bit easier so you don't have to deal with fractions. You can leave them in decimals. Think about how precisely you're able to measure. Record all of this information in the chart, and you can even take pictures of the items. After you have your object, your circumference, your diameter, then let's look at the ratio of the circumference to the diameter, and you might notice something. How many times does the diameter length fit around the circle? Does this number seem familiar? Maybe that graphic is showing you something. What is pi? Pi is a mathematical constant defined as the ratio of a circle's circumference to the circle's diameter. You can see that the circumference divided by the diameter is this constant number. Now, pi is a number, and we represent it with a symbol. Since it's an irrational number, it never terminates or repeats, so we need to leave the symbol pi, but it is representing a number. Remember the circumference formula for a circle? Write the formula for circumference of a circle in terms of diameter. Then try writing the formula for the circumference of a circle in terms of the radius. Why is the circumference formula of a circle c equals 2 pi r, where r is the radius of the circle? Think about it. Well, if we rearrange the equation to say 2r pi, 2 times r is the diameter. So that's where that formula comes from. Sometimes the notation in that order, we might lose that idea of the diameter is twice the radius. I really prefer the formula c equals pi d, and the reason I prefer it is because then it's less confusing with the area formula. Since the area formula is pi r squared, both the area formula and the circumference formula have 2's and pi's and r's in them, so you have to be careful. If you distinguish them a little better, it's a little easier for you and your students. Let's talk approximations versus exact answers. Since pi is an irrational number, if we substitute any value for pi, we've now approximated it. Sometimes we need to keep the exact value so we don't have approximations, especially when we're using them in lots of calculations. Exact answers will have the pi symbol in them. Approximate answers will not. Let's look at an example. Can you find the area and the circumference of this circle? Be sure to label your units. Find the area and circumference of the circle, labeling the units. Well, what we get is circumference equals pi times the diameter, or 2 times pi times the radius. We can see that the radius in this case is 6 feet. So the diameter must be twice the radius, which must be 12 feet. So we can simply write the exact circumference as 12 pi feet. Notice that our units are still linear or one-dimensional because we're only measuring the distance around the outside of the circle. The formula for area is area equals pi r squared. So if we take the radius and square it, we get 36 pi square feet. There's a great home circles activity that you could do that we discussed at the beginning, where you find all of the circles and you do a little bit of investigation. Try that. A great book to read about this is called Circumference and the Dragon of Pi, a Math Adventure. There's a lot of circumference books and they're really good. They're very high mathematically, but they're a joy to read. So check that out. Thanks for watching.